Hello, it's Keith here, and this is lesson 1 of the platform-specific series of my 609 assembly programming tutorials. In the platform-specific series, we go through a different system each week. We look at how to do a particular task on that system. Now, today we're going to be looking at the Dragon and also the Tandy CoCo. They're basically the same machine. To my knowledge, for the point of view of this episode, all the code will work just fine on either one. We're going to be looking at how to read in the keyboard and the joystick, and we're going to do it without using any of the operating system calls. And that's why it will work well on both systems, because the operating systems are different. We're not using the operating system, we're going straight to the hardware and we're going to learn how to read it. So we're going to be reading in the keyboard, and we're going to read in the entire keyboard matrix, and then we're going to read in the joystick. And the joysticks are potentially analog. I'm using a digital joystick today, but the hardware is analog, so we're going to have to cope with that as well. Okay, well, let's go over to today's code and let's see it in action, and then we'll learn what we're going to be doing. Okay, so let's just fire up today's example here. Now, we're not going to be showing keys as letters. What we're doing is we're showing what's known as the keyboard matrix. We're showing it as bits on the screen, and we'll discuss how we can work out what those keys are if we need to. Depends what kind of thing we're writing. If we're writing a text adventure, we're going to need to convert those key presses into actual letters. But if we're making a space simulation and we just need to work out which buttons are the missile button and things, then it doesn't really matter what the letter is, it just matters what buttons are down. So here you can see we've got a grid of ones here, and this is relating to the keyboard. And if I press the Q key here, you can see one of the bits has gone to 0, and that's W there. You can see various keys on the keyboard are affecting various bits, and it seems a little bit random, you know, Q, W, E there aren't really in any kind of pattern, and while 1, 2 and 3 are consecutive, if I do 6, 7, 8, well, they kind of aren't. So the keys do have some patterns to them, but it's a little bit jiggled up, and we'll look at that later. We're also reading in the joystick. If you see the bottom here, this is the raw data at the top, and then at the bottom here we're creating a bit mask where up, down, left and right are represented, and then the single fire button is represented as well. And you can see that just here, and this is the raw data. We're going to discuss how all of that works in just a moment. Okay, so that's the example code for today. Now let's just have a look at our code, and let's discuss how we actually read in first from the keyboard. Now the keyboard works like this. If we just go over to the documentation here, the keyboard matrix is represented in this format here. Now you can see here these are the letters or the numbers of the key, and then they are represented on this grid here. Now the way it works on the Dragon and most of these 8-bit systems is we select a row from the keyboard that we want to read in, and then we receive that back as a set of bits. So for example, if we decided we wanted to read in this column here, we would do that, and then we would get that back. And the example code we're looking at today actually reads all of them in, and so we only need this really if we need to convert back from the bits to an actual letter key. So how do we select the column that we want to actually read in? Well, what we do is we send a sequence of bits to FF02 here. And the way we select a column that we want to read in is we put a 0 in a mask where all the other bits are 1, and that will select the column. So we're selecting column 0 here effectively. What this sequence actually does is after each execution, we're reading in another row later on. Now, if I just temporarily disable this code here and run again, well, you can see now we're just reading in a single column from the keyboard. And if we just go over to the documentation over here, well, you can see that this single row will now be this one here. This is sort of column 0 here, and if I press the 0 key here, you can see bit 0 is flashing there. And if I then press the 8 key, you can see bit 1 is flashing. And then if I can find the @ symbol, which could be tricky, I cannot. I don't know where it is on the keyboard because of the mapping. The H key is just there, and then the P key is alongside that. But if I press the 1 key, you can see it's not shown at all because I'm only reading this column from the keyboard. Now you'll see the last one is represented as joy test, and you can see that actually change if I press my up key, and we'll discuss that in just a moment. So we're actually only getting 7 rows of the keyboard here with this read. There isn't an 8th row. So in that case, we're reading in this column here. Let's just go back over to our source code here. Well, how do we read in from column 1 rather than column 0? Well, we move the 0 across 1 here, And if we run this again, well, now if I press 0 again, which was the first one before, now we can't see that changing. Why is that? Well, if we just go to our documentation here, well, 0 and 8 are on column 0, and we're now reading in column 1. So now if I press 1, you can see that's being read in here. And then if I press 9, unsurprisingly, that's the next bit, and then A is the next one along, and so on. So basically, we select the column by the position of this 0 in this line here. So we're starting with it all the way over here, and then we're rotating it to the left, reading in successive columns until we've read in them all. So that's how we select columns on the Dragon, and effectively that grid we've got here, this is the entire keyboard. Now, as I say, we don't know what the keys actually represent as a letter, but from the purpose of detecting the pressing of the buttons, we have got that. So that's how we can read in the keyboard. We simply write a value to FF02 and then read one from FF00. Now, just for completeness, we do need to discuss what those are. These are the peripheral interface adapters. Now, they're quite complicated. We're going to see them various times throughout the entire tutorial series, and they can be reconfigured in various ways. You know, you can set these to be inputs or outputs. Now, if they were set up wrong, then this wouldn't work, but by default on a reset machine they will work just fine. So we're not going to discuss how to set them because it gets complicated, and as I say, I don't believe you should ever need to do that for today's example. Now, the FF00, the bits are all inputs. Bits 0 to 6 are for the key reading. Bit 7 is for joystick work. We're going to discuss that in just a moment. Now, FF02 is the one that selects the keyboard column. And as I say, a 0 bit would be there. Now, we've got all these other ones, but we're not going to discuss for setting these. And we've got some other ones that we'll see later on for comparing the joystick and the sound, but they're not relevant to the example we're looking at this very moment. Okay, so that's the keyboard. What about the joystick? Well, the Dragon joystick is an analog joystick. That means it can give a range of values, not just an on or an off. Now, from the point of view of when we read the Dragon joystick, we will get a value from 0 to 63. Now, the tricky thing with the Dragon joystick is we can't just read a byte and get a value from 0 to 63. That'd be far too easy. What we actually do is we write a value that we want to test, and we get a value back that says if the joystick position is over that test value. So for example, if we set 32 and the joystick is below that, we would get one result, and if it's over that, we would get the other. And so by testing various positions within the analog range, we can work out where the joystick actually is. Now, from our point of view, my tutorials, we just use a digital joystick. These are multi-platform tutorials, and I kind of lower everything down to the simplest, lowest common denominator. So we're treating it as a digital joystick. So what I'm going to do is I'm going to test sort of two extremes here and just see if it's over this one or under this one or in between the two, and I'll just convert that to a left, right or center value. So we're not going to do the scan of the entire range. Usually what you'd have to do is you'd have to sort of test the middle, see if it's over, test the 3/4 mark, and then test in between that and keep testing in between to work out exactly the position of the analog joystick, but we're not going to do that. Now, the digital to analog converter that handles this testing procedure also handles the sound. So first of all, before we want to mess with the joystick, we need to turn the sound off, otherwise we're going to be making crazy noises. And also we then need to select which one of the joysticks that we're reading from and which one of the axes of that joystick we're reading from. Now, the joysticks on the Dragon are marked as the right and left joystick. We're going to be using the right joystick, and each of those joysticks of course has two axes, an x-axis across and a y-axis down. So we're going to have to read two axes of one joystick to read in. The fire button is actually part of the keyboard matrix, so we're going to discuss that as well, but that's at least fairly easy to read in. Now, I said before that the Dragon has a variety of these peripheral interface adapters. Now, we were using this one to read in from the keyboard, and it also reads in for the joystick comparison, and also the fire buttons actually are represented here. But it also selects the sound source and also specifies the joystick compare values. So the value 0 to 63, which would either be a sound output or a joystick test value, is written to these top 6 bits here of FF20. But we need to configure the ports. We need to turn off the sound so that the joystick is being processed, and then we need to select which one of the joysticks and axes we use. And we use these addresses FF23, FF03 and FF01, and we're using bit 3 in all of these cases. Now you do need to make sure that any values you write to these ports don't cause problems for the other things that are using them, because the other bits have other purposes. Now the values I'm showing today will work for this example, but if you were doing things with regards to interrupts, then you might need to check the values. So you might want to read in the values and just change a single bit. But as I say, the values I'm using today will work for this example. Okay, let's go over and let's just have a look at how things work. Okay, so we've finished reading in from the keyboard. Now what we need to do is read in from the joystick. So what are we going to do? Well, first of all, we're going to turn off the sound with bit 3. We're setting bit 3 to 0 here. And we're also selecting a joystick. We're selecting the right joystick with bit 3 here. So we write a bit 3 equals 0 to FF03 and a bit 3 equals 0 to FF23. Now you'll notice there's a 1 bit here in both of these cases, and that selects the purpose of the port. If that was a 0, we'd be selecting, we'd be configuring the port for whether it's reading or writing. By setting a 1, we're configuring it as a data port. So all of these bits are a little bit tricky, and I'm only rushing over them. As I say, the idea is you can use this as a sample if you want to just read the joystick and you don't need to worry about the other hardware. Okay. So here we're selecting the joystick and turning off the sound. That's not all the work we need to do though, because we still need to select the axes, and we do that with port FF01 here. You can see here we're selecting the x-axis by writing a 0 here, but then later on we will do another write to that port, but this time we will write a 1 to bit 3, and that's selecting the y-axis. So that's how we select an axis. We are doing that with this port here. Now we do need to disable the keyboard to some extent. Now unfortunately the keyboard and the fire buttons actually share some ports here. Now as I say, when I press up here, you'll see that bit 7 of the keyboard matrix turns to a 0. Now that's not a problem because that isn't used by anything else. That's completely spare, so that's not used by any real keys. But when I press the fire button on joystick 1, you'll see that bit 0 and all of the columns actually changes, and that is a problem because that's a real keyboard row. Also, if I just go to hardware here and swap joysticks, now I'm effectively using the opposite, the left joystick, and you can see here that this is now changing to a 0 here on bit 1 here. And I believe the Tandy CoCo can support 2 fire buttons. I don't think this emulator can do that. I don't know if the Dragon can do it, but they would be using bits 2 and bits 3. So the keyboard matrix is unavoidably altered by this. Now we can't easily use the joystick and the keyboard at the same time, unfortunately, because of that. But what we can do is we can turn off the keyboard so that when I'm reading in my joystick values at the bottom here, you can see it doesn't matter what keys I press, you never see them represented here. And the way I'm turning off that keyboard is to send a bit mask with no 0 bit in it. If you remember, the 0 bit would select the column we wanted to read. Well, those joystick test values are represented in all the columns, so we just select no column, and that will turn off the keyboard. We can't turn off the joystick when we're reading the keyboard, unfortunately. Not the fire buttons, at least. Okay, we then select the axis we want to test with port FF01, and we're then writing a test value. So you can see here we're writing a high test value. It's these top 6 bits that are selecting a value. So I'm testing 56 here, and then we store that into FF20, which is the digital analog conversion value. We then read in from port FF00, and we're testing bit 7 here. Now if I just fire this up here, you can see these 4 executions of these tests on screen here. So this is the first test, and if I press the right key, we've gone over 56, and this has changed to a 1. Now the next test is much lower. This is just 7, and if I press the left key, you can see this has converted to a 0, because when I press left, it goes below 7, and so the bit turns to a 0, because a 1 would represent that it was over the tested value. So it's over the tested value when we're in the center for testing with 7, but it's under the tested value when we're testing to 56 when it's in the center. But when I press the right key on my joypad here, it goes over the tested value here. So this bit is 0 when it's centered, and this bit is 1 when it's centered. Now this is all a bit of a pain, but basically we're converting them. So that first line is testing the x-axis, and this bottom line is testing the y-axis in the same way. So I've actually doubled the code up here. We could have kind of reused some of this code, but for clarity I've doubled it up. So we're then selecting the y-axis and basically doing the same tests again just here. Now that's how we get the directions when we want to get the fire button. Basically we can get this from also the same port, FF00. The fire button for the right joystick is bit 0 here, so we're just shifting that out. Now we're shifting all of the bits of all of these tests out into the B register here. A register is being used for working with each of these hardware ports. The B register is the build-up. Now when the B register gets down to here, all we need to do is we need to flip the bits that are the wrong way around, because some of those bits are going to be 1 when the results are over the test and some of them are going to be 0. So we just need to flip the bits around so that we get a constant value. And the way I've configured it is to get a constant value where the result is a 1 when the direction isn't pressed and a 0 when the direction is pressed, as you can see down here. Now if you were writing a little game, what you would want to do is basically take out all this nonsense about showing the bits here. You would just want these rotations here. And as I say, you might want to use the code so that this part and this part here are shared, because it's basically the same thing of testing these digital ranges. So there we go. So that's how we can test the joystick. As I say, it's a bit of a pain. Hopefully you can download this code and you can make it work. It should work okay. It works on my emulator okay anyway. But as I say, if you want to really delve into it, you do have to start reading up on the peripheral interface adapter, which I can't even pronounce, so you can tell how difficult it is to work with. It's very confusing, and I'm doing my best to document it here. I really didn't understand it at first, but the more you read it, the more you understand it, and we're going to go over it a lot more. We can't avoid it. We'll see it over and over again. It configures parts of the screen mode here. It does the sound. It does interrupts the sound we're going to see. We're going to use interrupts, and it does that as well. It really does everything. So I can't give a tutorial on it at this stage. Firstly, it'd be very long, and some things like cartridge interrupts, I don't even know how you would fire a cartridge interrupt. So there's things that I'm not in a position to discuss, like printers. So we're just going to cover the parts of it that we need for each tutorial, and for today's tutorial I think we've covered enough. So as always, if you liked what you saw, please go to my website, download the source code and have a play with it, because that's the point of it. That's what it's there for. If you did like what you've seen, please like and subscribe. If you like the videos, YouTube will recommend them to other people. If you subscribe, then it will encourage me to keep making them, because I have to spend hours behind the scenes reading up documentation, trying to figure out how it works, writing the notes for my website, and writing test code, and it does take a long time. So if you do like it, please like and subscribe so that I can keep finding the time to do it. Whatever you do that, I wish you all the best with your programming. I hope you have a lot of fun with the Dragon, or of course the Tandy CoCo. Take care of yourselves. Thanks for watching today, and goodbye.